Hello, so tonight what I'm going to do is another toy hack. And I'm going to try to make this one really general so you can extrapolate it to any toy. Basically anything that's got a small DC motor, an old RC car, or something like the spybot, or battle bots, or any of those toys you might have floating around. Most of them have pretty small DC motors. Most of them have two motors that set their speed and direction, or propulsion and direction. This one's kind of cool. I'm assuming it has three. These are actually unpowered, but it does have this kind of cool wheel in the back. So I haven't played with this thing, or my kids haven't played with it for years and years. I think this outer wheel here rotates to give it propulsion, and then this thing swivels here. So I'm assuming there's two motors here. Plus it also has this gripper, which I'm hoping has got a DC motor in it instead of a solenoid. If I recall, it actually kind of went in slow and back. So I think it does have a DC motor. So the first thing I'm going to do is I'm going to pause this thing and start undoing a lot of these screws so we can see inside. And see if I can get to where these motors are, and I'll be back with you in just a few moments. Alright, so I got all the screws out. It was more difficult than it's supposed to be. One of them got stripped. And now, alright. Look at that. Okay, we are inside. So, let's see what we got here. Looks to me, this is clearly a motor that's going to be controlling the gripper, and we can see its gear drive mechanism here. My guess is there's a motor right here. And this one is probably the one that controls steering. And then propulsion, what do we got in here? Those are really small. It might actually be right inside here. So I think it drives directly with the motor down there. In fact, I might take this off. This has piqued my curiosity. I want to see how this works. It looks like these flexible wires here might be what actually give it the power to the small motor on the inside. So let me pause this, do a little exploring, and see where we can tie into these motors. This is obvious, this is obvious. This one's not so obvious, but I'm sure it'll work out. So I'll be back in a second. Okay, so I've learned quite a bit. I've been looking at it here for a few minutes while on pause. This is definitely a motor inside of here that drives it forward and backwards. This one is definitely the motor that rides on a gear. Here, maybe I can zoom in a little with my camera, and you can see the gear mechanism down below. In fact, if you look carefully, you can see that sort of classic-looking nylon shaft for that motor on the inside, which is pointing down, probably to a gear. And a telltale sign here are going to be these guys here. Anytime you see a cluster of these these big power transistors, you can pretty much figure it's an H bridge, and it's using for turning on and off a motor. So this is the circuit that turns on and off this motor. This circuit over here turns on and off this motor, and I'll probably see, and then we'll see some more of them up here where it turns on and off this motor going open and close. So look how it's got a spring return. We've got to be careful about that. We don't want to damage it, so it only drives. It just full throttles one way, and then it springs back, full throttles the other, and springs back. So it's just on, off, which is really convenient for us. The downside is this is a little bit tighter. Usually toys have longer wires than this. So I'm probably going to have to pause this and solder on some wires that are long enough. Something in the order of, I don't know, 3 inches or something like that. So that we can have a little bit of wire to play with so we can get it. Right now I'm picturing mounting whatever electronics I choose, whether it's a teensy motherboard and a DC motor driver, or if I go with an Arduino Uno with a motor driver shield. I'm mounting it up here, and I am kind of lucky. I mean, we have 5 AA batteries down here. We can actually just use this battery supply case to run whatever electronics that we're going to do. So we'll find that wire where it comes from below and tap into it so we can use it to power our electronics. So let me pause this. I'm going to be doing a little cutting and soldering and get some lengths of wire, and I'll see you guys here in just a few moments. Okay, so I've taken and soldered on some wires to make it a little bit longer. Soldered wires onto here, okay, here. And then I decided these are actually long enough. These little thin ones that came off the motor that drives the actual robot. I just removed them from the hot glue so that we could get some length on them and attach them to our motor drivers. And then it comes to the question of you know, how I want to actually do this. I do want to point out this is actually pretty cool. I'm going to leave some of this together. This was a voice recorder since it was a spybot. You could drive it into a room, you could hit record, and it would actually then record, I don't know, 20 seconds of audio, and you could play it back in the speaker. I'm going to try to leave all this together and probably debug it after a little bit, not in this video, and see if we can, you know, activate this as well. That would be kind of cool to make it autonomous and, you know, sneak into a room and hide in the dark or something like that. It would be kind of neat. And then what I do right now is I want to check everything. So I got some batteries here. I'm just going to make sure that my wiring's okay. So I'm going to stick this in here. See what kind of reaction we get. Oh, that works great. Let's see. It should just flip directions if I flip the wire. Sure does. And let's try this one. Make sure that we get some steering thing going on here. Alright, that works great. And try this one. Nice. And then let's see if the motor drives the robot here. This is harder to do. These are really thin wires. I can't even hardly see them. I'm using my glasses. Oh yeah, there it goes. Okay, so we have easy access to all the drives then. So now we have choices about how we want to hook it up. I've got a couple of different motor drivers that are really common. This guy here is ubiquitous. You can find it in a number of sites, including my own. And it's really easy to use. This will drive either a single stepper motor or two DC motors. You're going to put one DC motor into here, one DC motor into here. Then your battery that supplies power to the motors will come in here, and I'll show you that in a little bit in greater detail in a moment. And then these pins here is what we're going to use to control the direction of the motor. There's another one out there. I might just use this little guy. It's kind of cute and easy to use. Same basic concept. See if I can get this to autofocus on there. Alright, so you got A and B, those are your two, oops, come on, focus. You got A and B, those are your two motors. We've got power in, and then we have right here the same sort of selection about being able to input it into your whatever processor you're going to use. Remember, it takes two wires to operate a DC motor. So if one wire is high and the other one is low, the motor is going to spin one direction. And if I flip it like this, so this one's high and this one's low, the motor is going to spin the other direction. If I turn them both low, the motors are going to go off. So this will run two DC motors. The other option, and if I use, you know, this combination or this combination, mind you, I'll have to have two of these because there are three motors, and this will only run two, and this will only run two. I could run it off of something like this teensy, which would be probably the way I'll start. It's got a lot of I/O. I could even run it off a Raspberry Pi. That's a really old one. Or the newer Raspberry Pis. All these would be fine for running something like this. The other option is to do something with a classic Uno. I could actually run this off an Uno. Okay, just tap it into the I/O. As you guys know, or some of you know who've been watching my videos, I'm not a real fan of an Uno just because there's just not a lot of grounds and power supplies. You got a lot of jump ring and junk you have to do, but they do make some handy hold on a second, let me pause that. Okay, sorry, I was about to talk about these guys. This is a shield that I can go ahead and just snap onto the Uno like this, and then this will allow me to run actually 4 motors, so I can actually run the entire robot off of this shield. So that might be another way I might do it here shortly. I'll probably demonstrate both of them. Okay, so So let's get started with it. I'm going to pause this and get a board ready to hook up, and I'll see you guys in a second. Okay, so let me just show you this real quick. And again, keep in mind this video is not about hacking a spybot, okay? It's about hacking any small DC toy. So I took these two wires from this motor and I tapped them into A positive and A negative. Mind you, I don't even know. I just loosened the screw and attached them. It's a little hard to see, but they're in there with those screws. I don't even know if it matters at the moment. I have no idea which is forward, which is reverse. I just stuck them in there. Okay, we'll deal with that when we get to code. And then here, I've done the same thing with this particular motor. So now I have both steering and propulsion in this one drive. Now what I'm going to do is I'm going to take VCC and ground, and I'm going to plug these in right here. And in this case, I'm going to use one of Patton Robotics board, and I can use any VCC and ground. This side is switched. So for this little test here, I'm just going to stick it there and there. It doesn't matter. All the center pins on this board are positive. I've just got it set for 5 volts. All the outer pins are negative. Any of the center or negative pins will be fine. I just chose those two. This is more important. I need to get a hold of a couple of digital pins. All pins are digital. Not all of them are analog, but any of them are digital. So I'm going to take and plug these 4. 2 of these are going to be for the steering motor. 2 of these are going to be for the propulsion motor. I'm going to plug them in here like so. So this is actually more challenging than it was supposed to be. I make these things so small. Hard to get my fingers in there. Okay, I got that in. And let's just plug this in, I don't know, we'll plug it in from 0. We'll plug it in 0, 1, 2, and 3 right now. No, actually I'm not, so sorry. I'm going to put it down here because I might end up using serial communication. It'd be nice to have those earlier ports 0 and 1 available. So I'm going to plug it in. In this particular case, I'm going to plug it in 12, 11, 10, and 9. Okay? So now what I'm going to do is I'm going to write a simple piece of code and we'll test this thing out, and I'll be right back. Okay, so I got it hooked up. It's working really well. Notice I did do something here. I forgot that I should power the board with these 2 pins here. Okay, so I put a positive and a ground here. Let me get this out of the way. And I tethered it over to my motherboard here. Okay, like so, and then powered it into the voltage, the center pin and the outer pin. I'm also powering this off of the battery pack. Okay, so it's got plenty of power running the whole system, and I can turn it off with this switch. So you can see it's doing exactly, a little test here. It's turning left and right. Although you can't see it, but you can hear the drive wheel going. And the code is really simple. Okay, so what I did is, remember I hooked it up to pins 9, 10, 11, and 12 on the teensy, the lowest ones over here on the, and I'll show you again. If I come over to this, you can see it's these pins down here in the lowest corner. That's 9, 10, 11, and 12. It's hooked up to the I/O side. And first thing I did is set those pins to output. This is terrible code, by the way. It's not very clean at all, but it's a good test. And then, like I said, all I wanted to do was test it to see if it's working. So I set pin 9 and 10, high and low, and then low and high, and what you see is the direction changing. Okay, so actually 9 and 10 are powering the little DC motor down below, the one that's driving the motor to go forward. And then 11 and 12 are shuffling back and forth to switch directions. So I've only got a very brief bit of time on this video, so I'm going to end it with this and maybe a quick little tutorial here on how to use the other sort of motor driver. And I will see you again shortly.